Hello internet, this is LG Inverter Microwave. The model number is MJ3965BGS. This inverter has been serving us almost 4 years, but very recently it is not heating up, but all apart from the microwave functions, all other features are working perfectly. So just want to show you, say 30-second timer. You can see it is running everything. There's a sound coming up, tick 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 tick, nothing comes up. So turntable rotates even I place it over water. Let's time it up, start. You can see there's a tick 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 sound. It will not heat it up at all. So let's pop up the hood, then I'll show you the internals. Okay, I open up the micro oven cover and you can see these are the internal circuit. So these portions is primarily for the all the micro control, small power supply, and all the controller. Whereas for the heating component, this is the inverter board. This is not the conventional transformer based microwave. That's why it's inverter they called. So if you turn it on, now you can see 0. So you can see its turntable is rotating, and this is the sound you are getting. Hope my microphone can pick up. So it will not heat it up. So as long as turntable is rotating and everything's okay, no error, door alarm, so that means all the micro switches, let me stop it. All the micro switches at the door are perfectly alright. You don't need to check all the door micro switch. So your primary focus has to be on the inverter board. So and you heard the click sound, that means the power supply is coming, the inverter board is unable to switch. So step 1 is that for the similar problem, ensure that the turntable is rotating and there's no error, door sensor error. Then you have to focus on this inverter board. So how to check methodically, I'm going to explain here. So first of all, I turn it off to make sure safety comes first. So turn it off. Okay, it's turned off. So I'm going to check first the Magnetron. I think that's good. That should be the perfect pronunciation. I think so. If not, apologies. I am using my left hand to unplug it. Okay, so I'll get a multimeter and show you how to check. Continuing. So my multimeter in ohms mode, that means in resistance mode, not in continuity mode, just to measure the resistance. So you check this resistance. So I'm checking this resistance has to be around 0.1 to 0.2 ohms. That's the overall impedance of Magnetron. Okay, you can see 1.2. So that looks okay, but in shear, so this is the one I'm measuring. If you can focus it properly, this 2 terminal I'm measuring. 2 terminal reading is 0.2 ohms. So basically this is the same lead resistance, is similar to this lead resistance, 0.1 ohms. Just make it far, not getting the proper angle. Okay, just to check, bring the multimeter here, easier. Just to check the is it shorted or not, with one lead connected to one of the pin and touch the ground, it should not show a continuity connection at all. So but here we can see is less than a mega ohm. So this magnetron could be faulty. AC is getting consistently 845 kilo ohms. So which by design should not get less than a 1 mega ohms. It should be overload, it should come. So either this could be issues or the inverter board, and let me pull out the inverter board to show you further. So just to take out the inverter board, undo. This is the power connector. This comes power supply to inverter board, and this is the control and current sensor. So it provide the control, what should be the watt level, and this connection goes to magnetron. Okay, so I need to undo this, then I try to pull out. Hopefully I'll be able to pull out, not sure, otherwise I have to open the bottom 4 screw. Let's see if we can not have to open the entire plastic casing. Okay, pull out. Let's see, can I pull it out? Okay, so I took out the inverter board. So this is the inverter board. So I have a bad lighting. Okay, so this inverter board comes with rectifier bridge and 2 full bridge. This angle I think properly might be better. Yep, 2 IGB transistors. So these are the IGB transistor, and these are the high voltage diode which actually discharges this coil. This is the high voltage transformers. This is the primary, and these are the 2 independent coils for the secondary, and one is current sensor. So 2 coils, so is called EST, high tension transformer. Okay, so I have checked the board. This board I'm unable to find out any faulty component, but proactively I replaced the 2 IGBT I bought online, and I replaced it, as you can see. And parallelly I bought a new board from LG as well. So I'll be swapping this board now just to test out my theory is that this board having an issue on the Magnetron. But one difference I have found out is that one of the bridge, I think this is going to be too technical. Those folks not having much electronics exposure. I'm not going in details in troubleshooting, so my apologies in advance. But when I compare between these two IGBTs, I found that I'll show you. Let me wear my head cap. I don't know how I'm going to show you. If I get a pair of hand. Okay, so again, just to repeat, this is the new board and this is my old board. So if you can measure the IGBT, this is the emitter, this is Q2 and collector. So absolutely there is no short. You can see you are getting a reading. So just say as long as you are getting a reading, it's not very close to short circuit, it should be technically fine. So I'm getting a reading, but if you can see, this is the gate pulse. Sorry, I say initially collector, my apologies. So this is the gate one. So gate, emitter, Q2 and this is the Q1 and Q2. Sorry, so this is gate, emitter, and this is the other lead. This should be the collector. This is the collector. Okay, so in between the gate and emitter, so gate is the controlling pulse, that is the diode, it's a Zener diode. You can see is forward bias is 571. Once it goes to reverse bias, nothing. Perfect. But the question of this one in the Q1 IGBT, okay, reverse bias, okay, 572, okay, this 205. It's showing some resistance here. If I do the same thing in the newer one, so it is also pretty much the same. So that's why I said this is a 10k resistance. This is a 10k resistance I put. It's a 10k. Yep, so 10k resistance. So technically I am unable to find any fault here. So one of the capacitors here is a designing such a way it's a zero resistance. Hereby also is zero resistance. So this is the switching one. This is the voltage regulator. This is the microcontroller which actually controls the pulse and currents, and these are the feedbacks for the optocouplers. So okay, I disconnected this, the connection from Magnetron, and I'm placing my multimeter again just to show you the problem. So initially on the old board I changed proactively, I changed the IGBT, and this diode is at least 3 to 4 volt, at least 3 volt. So you need to provide an external power supply here, then only you should be able to check the voltage drop across this the anode and cathode. Okay, so with the multimeter, if you check in the diode mode, it will always show open. So just to show you what I mean here, so this diode, I don't know with this, I'm holding one hand. Okay, so if I touch here and touch here, it will not show any reading. I want to show you. So sorry, I'm just holding. I do not have a head camera, so I'm unable to show. So this diode, if you measure with diode mode, it will always open, just to let you know. Okay, so this diode could be faulty or could be open. You only able to measure with the multimeter if it is short. If it is open, there's no way you will be able to confirm it unless you apply a external voltage and check the voltage drop between these two terminals with the multimeter. I think if you search the internet, YouTube, there are so many videos to show you how to check microwave diode. Okay, so just additional note here. Okay, so come back to my initial diagnosis. Again, I'll show you in my multimeter in ohm mode. Okay, and as I said, this 2-port ohms should show 0.2 ohms, but at the body it should be always open, but here you see it's less than a mega ohm, so which is not supposed to be. So I have to replace this for sure. Then I'll conclude the video. Once I have that replacement part, we'll revisit this. Okay, I already got the new replacement part, so I want to show you the difference. You can see replacement part is 2M286. Here also 2M286. This is on my right, this is the old one, and this is the new replacement port. So here these two, you see 0.1, 0.2, this is the right resistance for the coil, but one of these coil, if you touch with the body, it shows less than 2 kilo ohms. That means this is faulty. But however, if you see, this will show the exactly same 0.1 to 0.2 ohms, but once you touch the body, this is completely isolated, there's no resistance. So this is the good one. This is how you should identify. Now the question is, why at the first place I didn't pick it up? Because from my experience, I noticed that the magnetron failure is always very rare, less than 10%. So I always focus on the electronics and electronics percent. But if you see the older one, so I missed out one basic principle of electronics. Since I did not take it out, I did not do a physical inspections of this unit, because in the microwave it was mounted like this orientation, and this orientation I have no visibility of inside magnets, the waveguide magnets. But if you see very closely, here the waveguide magnet has a big crack. You can see this magnet. Okay, let me pop it out. You can see this magnet is not uniform, this is got crack, so something might have went terribly wrong, so that's broke the field. But however, this is the newer one, you can see all the magnetic rims are uniform, so that's how it's difference, make it difference. Now I'm going to put back in the microwave, and from there we'll take on next. Now I have installed the Magnetron and just power off the system. I'm just starting. This is the first try, unedited version. Let's see how that goes. You can see, you can hear the sound. Waveguide open. Now waveguide is closing. This is the waveguide. Waveguide aperture. Yeah. So this microwave is fixed now. Here you can see inside I put a half cup of water, which is not ideal to reheat. So just for try, 30 seconds should be good enough. I don't want to get a 3rd-degree burn. Just take it out. Yep, I can feel it is quite a warm. You can see it's quite warm. The texture changed. Yep, even I can feel it. It's warm, so it's fixed. Now I want to bring the cat out. At the first go, you saw in the video initially, I changed this inverter board. So you might ask, if you knew this magnetron was faulty, why I had to procure separately a new inverter board. Um, First of all, I did try to fix the original board and change the IGBT components and the two discharge diode. That did not fix the problem. Then only triggered my mind I should check the magnetron, so which I should have done at the first place. So at the when I was doing the comparison, I was talking about the visual inspection. So the first telltale sign should be the two magnetron coils should be isolated from these chases. Should be isolated. That means you should not have any continuity between this one of this terminal and this body. So this is the first check. I failed to do so. This is the genuine acknowledgement from my side, and I was unable to do the visual inspection, because if you really want to do the visual inspection, you need to take it off this magnetron, which I did not do at the first place. So I saw it was not heating up, so primarily it should be the inverter board. That's how I worked on, and since I was unable to, there's no problem, and I put it back, and I thought maybe there's some other components failed, so I had to procure a new one. And once I replaced the new one, still the same, then it's prompted me something else, that should be the magnetron. Then when I, at the starting of the videos, you can go back, and here there's a pause, there is a shot, and it slips my initial inspections.